Start, continue. Okay, live.
Okay. Right. Welcome everyone. Welcome to physics, and welcome to the options evening. Physics is an amazing subject. I spoke to some students today, and they said they were really enjoying the A level. They like all the practicals. We normally do a practical every other lesson to mix a bit of theory and practical. They found that they were saying that physics is really interesting because we unpick how things work, and they also said it was quite challenging trying to make sense of some of the really more complex ideas to do with physics. But in the main, it was great fun, and they loved doing it. And they certainly said it was a bit more chilled out than chemistry. So in terms of where it might lead you, it will be careers such as civil engineering. So we've got bridges there, but it could be equally things like tunnels and buildings. Civil engineering is really important for our infrastructure. And then moving on also, it's not a very well-known fact that the UK is a massive exporter of astronomy and astronomical kit, and in terms of research and building satellites, for example, for the European Space Agency. So certainly there are lots and lots of openings in careers for that. And then one that's close to my heart is mechanical engineering. How we make things go and make sure they don't break down, including and alongside to mechanical is also aerospace engineering and dealing with aerodynamics. There's also massive amounts of work in medicine for physicists, especially on the radiotherapy and radio imaging. Lots and lots of doctors. Well, the two doctors that I know, who are my friends, have always held physics in good regards. One of them did physics A level. She then found it a lot better than her colleagues during her medical course, because a lot of the content that we cover is applicable to things like radiotherapy. And then there is, of course, the finance industry. So people like Goldman Sachs. They just like people who solve problems and are good with numbers and model situations and do calculations. Because if you're just adding up numbers and modeling how a market behaves, it doesn't matter if it's physics or if it's a financial endeavor. And then moving on, we've got electronic engineering. Again, that sits firmly in the modern world. It's how everything works, isn't it? With electronics. And alongside that, we've also got things like software engineering for computers. All of that will need a physics A level. There's also, of course, physics research, really expanding the boundaries of how the universe works, way inside the atom, really unweaving how the universe works, which is amazing. And the nuclear industry then follows on from that, in particle physics. It's going to be a massive part of our future, the nuclear industry, because there's no way to weigh up the renewables, not renewables energy equation for the 21st century without talking about nuclear power. And the pressing problem, especially with COP26 at the moment, would be environmental science and climate change, and solving all those problems that are going to come up that need solving, like capturing carbon or mitigating the effects of climate change, organising clean ways to travel, for example. All those things will need to be sorted out by physicists and engineers. And then do physics, because simply physicists earn more cash. They're likely to earn a fair amount more than other subjects that you might do. So physics is amazing. It's hard work, but it's great fun, and it's how the universe works. And with that, I'll hand over to Mr. Sykes, who'll carry on the rest of the presentation.
Thank you, Jay. Thank you, Jay. Let's have a little look at where we're heading next. I love A-level physics. We get to explore the awe-inspiring wonders of the incredible universe, from galaxies, stars, and looking at the Big Bang itself. We also then delve deeper into the absolutely tiny subatomic particles, and we can see what makes an atom, what makes a nucleus, what makes a proton. And A-level physics will explore all of these fascinating topics. We really like our students to keep an eye on what's in the news in terms of science discoveries, and this is something that's really captured the excitement of physics teachers and physics students alike. The James Webb Space Telescope is going to be launched within the next month or so. This awe-inspiring piece of technology and science will be going out, being sent up into space to look far into the deep and into the early universe. This is something that has really, really caught our eye, and it's something that students and the teachers really want to know much more about. We are hoping to have one of our Big Bang breakfasts where we get a gathering of interested students to find out about this launch of the Space Telescope in December, and we'll have a catch up and just a discussion about this really interesting, fascinating piece of science. We've been fortunate enough in the past to have some links to some really great physicists, and this lady, Dame Jocelyn Bell-Burnell, was awarded in 2018 the Special Breakthrough Prize in Fundamental Physics. They felt that perhaps she may have missed out on the Nobel Prize, where her supervisor discovered, she with her supervisor discovered radio pulsars, and so they felt that this prize that she was awarded many years later went some way to make right that earlier question mark where perhaps she was left out of the prize. And I'm delighted that she came and visited us at JCG, and there she is with some of our current Year 11 students there. And we had the chance to hear her speak and hear about her thoughts about really fascinating careers in STEM. Her prize money has gone on to fund the Institute of Physics in something called Limitless. I'd like to just share a video about that just now.
What does a typical physicist look like?
Most people who I know who do physics are boys.
I think physicists tend to be rich white people.
To pursue physics, you have to come from a wealthy background.
I don't feel comfortable doing physics.
I think there's not a lot of girls in the STEM sector.
I guess if you like physics, then nothing should stop you.
Someone's always going to tell you no. As long as you think you can do it, then you should go for it.
Physics is for everyone. It doesn't matter how much money you have or where you come from.
People go into it thinking it's a lot more complex than it really is.
It's not based on history, it's up to you.
Just because I'm interested in physics doesn't mean I have to go to uni. I can do an apprenticeship as well.
Both my physics teachers are girls, so it's really inspiring.
Physicists are just regular people.
Physicists could have silver nail polish.
Anyone can be a physicist. It doesn't matter who you are, what you look like.
If you feel like you can do it, then do it.
The future of physics is equal.
And I think that video really showed that people doing physics. That video went to show that people studying physics now at A level and onwards at university can solve some of the world's problems in terms of climate change or our aging population, and the fact that we need to get smarter solutions to solve our energy crisis. There's a huge amount of problems out there waiting to be solved, and you can be a part of that. We think that A-level physics has a huge benefit to your transferable or employability skills. We think it advances your talent for teamwork, helps improve your organisation, helps develop your ability to understand new concepts, and of course it hones your aptitude for maths and problem solving. We do ask students to take maths and physics together at A-level. They're a really, really strong combination, and those maths skills will really support your physics understanding. And we found that the students that do take maths and physics together do achieve the best grades. So we ask that that's a requirement now. We look at some of the applications of physics. We look at how it can be used in car safety and how airbags consider the change in momentum. And we look at how satellites can be used for monitoring and weather and communications. This one goes out a little bit open to the floor now. So let me see if I can get this up in one image and have a look at the Q&A section here. So I'm not sure if I can do both of those things. Mr. Aguiar, I wonder if you could perhaps read if we get any Q&A messages. So if people can go into their question and answer box, perhaps we can get any clues here. We'll have a look at this first one here. So these are all types of medical imaging. And we've got a skull. Can anybody suggest what type of medical imaging this one might be? Ooh, so this is the skull in the top left-hand corner. Not sure if that's anyone going on the Q&A there. Mr. Aguilar, have we got any takers for that?
Oops, I'm muted. Yeah, nothing through so far, I'm afraid.
Oh, right, okay. Should we give them some clues maybe? In fact, we've got one of them is an X-ray or possibly a CT, computerized tomography scan. We've got an MRI scan in there. We've got ultrasound. Some people might have got that one. And the last one, tricky one there, is a PET scan or positron emission tomography scan. And I'm not sure if anyone's thrown anything into the Q&A. The first one here was X-ray.
I've got an anonymous, somebody said X-ray.
X-ray, we've got a winner. Well done, anonymous. Fantastic. The second one here, reading across the top here, perhaps you'll know that this is the ultrasound. Coming down to the bottom one where you can see the eyes nice and clearly. We think that's a computerized tomography or CT scan that's made up of lots of X-rays put together, so you can see slices through the human body. This one that's showing up lots of soft tissue in the brain is an MRI scan. And finally, this slightly unusual one here is positron emission tomography or a PET scan. So we'll be exploring those types of medical imaging in more detail in A-level physics. Again, another one open to the door, open to the Q&A there. What do these have in common? This is hesitant enough at the best of times when we've got people in a room. So if anybody manages to throw anything into the Q&A this time, I'll be very, very impressed.
Yeah, I've got 2 messages. I've got 1 MRI scan, and somebody else was saying for medicine, what combination of science subjects is best?
Oh, that's a great question. So we've got for medicine, what combination of science subjects is best? Well, I think the strongest combination that I would suggest would be maths, physics, and chemistry. There's lots and lots of links and overlaps in those subjects. You need chemistry to do medicine, and they really support each other in many, many ways. So maths, physics, and chemistry as a combination A-level. It's incredibly powerful, incredibly strong, and it certainly opens your door to medicine and many, many other subjects.
Yeah.
I'm aware that there was a bit of a delay, perhaps, on the Q&A coming through and this question, but these 2 things have in common. We've got some red blood cells there and a speed camera. Well, they both can use the Doppler effect. So you send a pulse, whether it's a pulse of radio waves, and that rebounds off something. It may be the red blood cells in blood, or it may be a moving vehicle. It returns to the sensor, transducer, and there is a shift in the frequency and shift in the wavelength, and it's that change in frequency that can tell us the speed of the blood in an artery or the speed of a moving car, and we can work out how fast these things travel.
Mr. Sykes, I've had a couple of questions. So question 1 is the exam format the same as GCSEs at A levels?
Good question, thanks very much for that. So at A level, we've got 3 papers, papers 1, 2 and 3. First 2 papers are 2 hours 15 minutes. They're all taken at the end of the A level course. And then paper 3 is the slightly shorter paper, but it's unified, so it's synoptic and looks at all of the sorts of the topics that we've studied throughout the course. There's also the practical endorsement at A level there. Any other questions, Mr. Aguiar?
Yeah, got a couple of just coming through. The next one is, I'm considering physics, but is it possible to take without maths?
Unfortunately, we found that people really struggled without maths. So unfortunately, it is a requirement now to do maths and physics at A level. But it is a strong combination, and we really think it will help you get the best grades in those subjects.
Yeah, definitely. But when there's one more, again, anonymous, my daughter is very interested in F1. Would mechanical engineering be the best direction for her using maths and physics? Can I jump in there and say mechanical engineering or aerospace for F1? I did aerospace, and lots of my colleagues were very interested in F1 because of all the aerodynamics, and you learn enough mechanical engineering in the aerospace engineering degree to be able to go into F1. So I'd say mechanical or aerospace would be ideal for F1.
Thank you. We need a few things from you as a student. We need an inquiring mind, a thirst for knowledge, a commitment and a willingness to try your best. We need you to do your homework every week to the best of your ability, to find out about interesting aspects of physics in your own time, and to enjoy physics because it is fun. One of our former students, Amina Hassan, who's now Amina Khosrow, has now gone on to work for an incredible eco-friendly car manufacturer. She used to work for Jaguar Land Rover, and in the last year or so she's transferred to Arrival. And she sent this short video today that I'd like to share with you, and I hope to show it now. Let's have a quick look at this.
Hi, I'm Amina Khosrow and I'm an engineer at Arrival. My role is project manager for the after sales department. Now you might think that a role of an engineer is a certain way. We're hopefully going to break that stereotype down for you and show you the wide range of roles that are available here at Arrival. Now all of our engineers try and make a radical impact on whatever they do. We like to be the best out there and also make an actual impact to our future. From a sustainability perspective, that mission is very critical to us. We try and minimize waste where we can, and we actually look at the impact of what we're doing to the world around us and the future generations. So your role at Arrival might range from software engineer to working on the delivery, hands-on, or traveling to different sites to physically fit in components or to meet customers and clients. The beauty of this is a role at Arrival is just so different and broad. Whatever your skill set is, you can really incorporate that into what you do. Personally, for me, my background is mechanical engineering, so I love getting my hands dirty. And I've done that in previous roles, but I'm also very organised and creative, so I like managing special projects and also managing the team's overall mission and objective. Whatever excites you can easily be incorporated into this umbrella of STEM. So if you are considering a career in STEM, it's definitely worth doing so. Get some work experience and see what there is out there and really explore. And don't let the fact that maybe you're not great at maths or don't actually like mathematics put you off. Whatever skill set you have, utilise it, because no one role in the STEM sector is ever the same, which is awesome.
So thank you very much for joining us today. It's been lovely to have you all on board, and hopefully you'll take A-level physics. Thanks very much, and bye for now.
Okay. See you soon.